Visit with our brother Booker T. Coleman, a student of our mighty scholar, John Henry Clark, who has become an ancestor now, whom we still continue to celebrate. So you can consider this as part of that celebration. We're here to look into the role of the Shabaka Stone in the discovery of the unified family. Yes. What I was saying basically was about the celebration which we were here for today in honor of Professor Henry Clark, our teacher and elder, and now an ancestor for us, who taught our beloved brother here right from the age of 12. And in his words, he had no choice but to do what he's doing right now. And we're quite delighted. The brother had studied the unified field theory account that was presented in our time press, and somehow had made a connection with the Shabaka Stone, which he would like to share with us. And in the process, we can share that testimony, which is certainly very, very spiritual, very, very important, and a very serious, if not critical, component of our whole being as a people, in terms of our history, in terms of the destiny that surrounds the unified field theory, or the theory of everything, where we're actually destined to come up with that theory. And that's basically what we look forward to. Brother Booker T. Coleman, a distinguished citizen of Africa, an excellent scholar, to share with us today. Thank you, brother. Okay.
Thank you, my brother, Dr. Oyibo. And I am more, if not just as in awe of Dr. Oyibo and what he has done. And as he said earlier, being a student of Professor John Henry Clark, I was introduced to culture and history. And being a teacher, everything I've ever learned, I've always tried to break it down on a child's level. And my strength in education has been being an early childhood teacher. Because in being an early childhood teacher, I've had to break things that would be very complex down on a very simple level. I've been studying this for a while. This is astronomy, this is physics, all of which I was not interested in when I was growing up. The interest came when I understood that this was my history and my culture, our history and our culture. And I am in awe of Dr. Oyibo because if justice is served, if Ma'at is righteous and is recognized, he will be a Nobel Prize winner. Because what he has done, literally, I know is correct. I'm not going to speak on others. I'm not going to use other people. I'm going to directly deal with Dr. Oyibo's work here. I do not have the mathematical background that Dr. Oyibo has. However, in looking at it, at his formula, I know it's correct by the variables that he's given, by the letters that he has given to each essence, and by studying this Shabaka stone. Shabaka was a pharaoh of the 25th dynasty. I'm afraid of dates because we're going to find out that we're much, much older than we really are. However, using what we have today, you know, if you can't get to the star in the long distance, what you do is you hook up with every short distance star until you get to your long distance. So we're going to use with what we have now to try to reach back and touch fundamental. What Dr. Oyibo has done, put down on paper, literally will change the way humanity thinks. I would even dare say it will usher in a new level beyond Homo sapiens sapien. But more importantly than that, I think we will remember our history. Much of what Dr. Oyibo has done, with all of my admiration, I think he is recalling, he is remembering what we have forgotten as a people. The Ma'afa, this period of enslavement, has put us in the like of a sleep. Many of us are coming up out of this sleep, and I think that while this seems futuristic, it really was our past. And I think that we have devolved as a human people because we've allowed people who know not to tell us what they think they know. And what Dr. Oyibo has done is changed the way in which we look. This will change the way people think. This will change the way in which we act. This will change the way buildings look. This will change the way in which we talk to each other, the way in which we build things, the way in which we do things. Because when you come in contact with something such as the Shabaka Stone, it changes fundamentally your thought pattern. You cannot think the same way. Shabaka Stone, they say, was written approximately 710 years before the Christian era by a Pharaoh Shabaka of the 25th dynasty. However, in all of this, what you notice is that there are two horizontal lines that go across. There are approximately 62 that go down. And between line 24 and 46, it's almost obliterated because the people, when they found this was found, and people used this as a tethering stone. In other words, when you wanted to ground grain, you would put the grain on a rock and put another rock and then beat the rock. Well, this was the bottom rock. So it is obvious that the peoples living in Egypt today could not have been the masters of this work, for if they had been, they would have known never to do something like that. So it's obvious that the people who did this were no longer in the land or were not in control of the land. So it is of an African origin, the 25th dynasty. The first two lines, written by Shabaka, tell of how they came upon what is known as the Memphite text, which is the original text. And because we know that our Kemetic ancestors wrote on either papyrus and sometimes on leather, we know that Shabaka is saying that it was worm-eaten, but that it was such a dynamic scientific treatise on the coming into being of the universe, it was too important to let it go into oblivion. So he had his scientists and his artists rewrite it in stone. So you get the concept of it's written in stone. In other words, it's permanent. This is where the concept comes from. Shabaka was saying, we will write it in stone for all posterity so that it will never be taken away from us. And it's so interesting that even though they beat it to death, it still came alive. This story tells of how the universe came into being. It tells of how all and everything were in the waters of Nun in the very beginning, matter. And that at some point in time, rising through the water came Ptah. Dr. Oyibo has also done a great deal of work on turbulence. Turbulence, as I saw it, and again, what's going to be great about this conversation is I'm learning. I'm not here to lecture or to preach. I'm here to learn from Dr. Oyibo from a mathematical perspective what I am theorizing, what is known as metamath by Dr. Theophilio Benga and Dr. Sheikh Anta Diop. Those thoughts that come into your mind before you write it down. I have thoughts, but he has written it down. I'm hoping to share my thoughts to see where it fits in all of this. So as we go through this, we'll learn how all of this occurred. Because of the nature, I would just like to back off and just get deeper into the conversation, because I think that I've pretty much finished my introduction. But I am very happy to be here, and it's been months and months since I've been saying to Dr. Oyibo that we need to get together, because again, I have his book. And the brother did great work to get me on discount. But if you knew how much his math book cost, I mean, it's an expensive, I mean, Dr. Oyibo, it was $125. And he got me discount. So you know I bought two. Because I'm not letting nothing happen to this. But when I read his book on turbulence, turbulence is Ptah. It is the primordial scission. From my mind, it is that first inkling where something comes from nothing, because there is no such thing as nothing in the African world. Nothing is something that you can't see. But nothing is still something. In the English language, nothing becomes nothing. But that can't exist in the universe because everything is something within the universe. Even if it cannot be seen, it is something. It's just unseen something. So we're dealing with the unified field theory, which I truly believe is, as defined by the Shabaka Stone, the waters of Nun. That to me is what the unified field theory is, or what is known as GUT, G-U-T, the Grand Unified Theory. Einstein claimed to have died trying to find it. And I'm saying had he just looked to Africa, he would have found it. So that on one level, Dr. Oyibo's work, the Grand Unified Theory, this formula, is Nun. His book on turbulence is Ptah, and Atum is the consciousness that comes forward when you understand the Grand Unified Theory and turbulence. Now we need specificity from Dr. Oyibo in terms of math. Let's get it on.
Dr. Oyibo,
Yes.
I just want to interject one thing. So that, later on, when people are looking at this, they will better understand exactly what unified theory is. So if you could explain that in terms of what it is we're really looking at.
Yes. Well, the unified field theory is a theory embedded in the human spirituality, in reality, that was supposed to show the connection, the unified position of all the forces. That says the forces, if they're called forces, just like the human family, you should have the same origin. Okay, if you're a human being, you must have some kind of origin, common origin. Africans have the same great-grandparents, and and so on and so forth. So forces are therefore thought to have a common origin, except that the sciences, as they have it, have not been able to show that common origin. They will study those forces separately. They will see the effects. A few cases they have commonalities, other times they're separate. So the principle then of the unified field theory is to unite all the forces.
What are those forces?
Well, in reality, humanity doesn't know all the forces, but they claim to have identified four, which are the gravitational force, which holds the planets and the universe together. Then you have the electromagnetic field, force, which holds, you have the electric fields and magnetic fields. They're responsible for energy production and so on and so forth. It's a very unique kind of field that moves electrons and all kinds of subatomic particles, and any object that has elements of electric or magnetic field or components in them. Then the third category, or which are actually two, are the so-called strong forces and the weak forces. The strong force binds together the repelling components of the the universe system. For example, if you have two magnets, you have, the like poles would repel, okay, and unlike would attract. And so what happens is when you have those together, they will be bouncing away. That's a very, very strong kind of situation where they're trying to push one another away. So if you can imagine a force that will keep them together, force them together, that is the one that's called the strong force. At the same time, there are other subsystems of the universe that may not be repelling as much. They have minimal repulsion. They may have even some attraction, but they still need to be kept together. They could even be neutral bodies. They don't really attract, but they need to stay together. You know, they don't attract or repel, but, you know, they need to be staying together. The force that keeps those kinds of components together is called the weak force. So these are the four that have been identified up until this point by scientists and mathematicians and physics. So there has been a study through generations of humanity. And what Brother Booker is basically addressing here in terms of the connection with the Shabaka, giving its historical time kind of setting, is that it was always there in the Shabaka Stone. But in relatively recent times, yes, I was finishing the definition of the weak force and the fact that humanity has been looking for it, and basically the relatively short past, the people with the solution, of course, had been under siege and under all kinds of trying moments, and so have been put in a position that they were not really looked upon as the ordained source of that knowledge. Like Brother Booker had pointed out, the solution had been, buried already in the Shabaka Stone. And it would then seem that there is some level of destiny then the African, wherever he or she is, was supposed to come up and share that with the world. But because the African, ironically, was the least expected to do that due to one lack of information or another, they were not considered at all. As a matter of fact, physics and mathematics, especially mathematics, which our ancestors were used as a source to bring it to the world by the Almighty God, you will be surprised to know the level of African people getting degrees in those areas. Certainly in physics is quite similar. Of course, as is very clear in history, geometry was what our ancestors did probably better than anyone that has lived on the surface of this earth. Not only did they do the theoretical developments, but they practicalize it in terms of the pyramid and stuff like the Shabaka Stone and the use of lasers and sophisticated kind of incredible dimensions and extensions of mathematics or geometry beyond the level that most people are familiar with. It's as if it's actually a spiritual expression, which is why the English author, who wrote a book, The Fingerprints of the Gods, Hancock, called the book The Fingerprints of the Gods. In other words, that the awe which overwhelmed him in looking at the practicalization of geometry, okay, and the other sciences by our ancestors were so high, such a high level, that he couldn't simply believe that that could be done by human beings. That's a testimony to the kind of sophistication and God's blessing that has been bestowed on our ancestors. But ironically, in the present time, it's hard to see the evidence of that in terms of the number of graduation of people of African descent in mathematics or geometry or physics or even chemistry. The name chemistry, is actually the science of the Kemetic people. That's where the word came from. Chemistry, Kemet, chemistry. And when you put math and chemistry together, you get physics. Okay, so there are quite a bit of evidence in terms of historical and even, goes beyond history in terms of a spiritual, sign that says, yes, these are the people that were actually ordained to bring such information, and the importance of a unified force is actually going back to the concept of the Almighty God, because that's the most awesome force. And, when you're looking for a unified force, you are indeed looking for the Almighty God, the Creator. That's the author of force. That is the entity behind any motion that exists in the universe. And so unified force is the world. Unified force is the universe. Unified force is the embodiment of creation. And that's why it is so important. We can transform within a conservation, as we talked about, but that we are basically part of that unified force. Okay, we could go from one form to another, but we come from one original source, and that's basically what the search for unified field theory is about. But it takes some history. It takes the current realities in education and the university systems, where, for example, in my search, when I was starting out for mentors in terms of people of African descent, it was basically non-existent. So like I said before, this development is thoroughly unexpected to the world. No person would have ever guessed in any way that it would be somebody of African descent that was going to tell the story. And as I've shared with most people that I talk to, the reason that is the case is because the ancestors, have the keys to the truth. And so the rest of us who came later, one way or the other would continue that to tell that truth. And so, this is the context in which we're discussing the unified field theory. Because it's a central force within the creation itself, it has so many implications. And like I said, when you can link it to the force of creation itself, which is the Almighty God, then you can understand what I'm talking about. People, for example, want to go back to understand creation. You know, is it the Big Bang Theory? You know, what happened when time, the original, when the time began, okay? And so you can see then how it is important not only to find the unified field theory, but to use that theory to go back in time to actually get a better sense of how the Creator actually created the universe. Okay? So it's not a trivial matter. It's not a trivial undertaking. It's not a frivolous one either in terms of its importance. So it is within that context that you know, I began my search very young when I started, as I mentioned in the interviews before, basically in the high school. But before then, the elders who I studied under had already been giving me a lot of information in terms of, you know, my position, you know, as a people, as a member of a people, of a race, what my job was supposed to be. You know, by looking back and seeing things, I guess I must say that I may have been quite fortunate, you know, to have that kind of education and information, which of course made my search a lot more focused and more, you know, inspiring and more energetic for me. So, so of course it began, you know, formally or semi-formally at the high school level, okay? But even in elementary school, you know, I tried a few things, you know, thought-wise in terms of thinking about, you know, what to do with mathematics and so on. To, you know, to go along that direction, I didn't formally know it at that time, but I knew, you know, somehow that was where I was headed. So then in the high school, one of the early things that I remember in the high school was taking a formula, which I've shared with many people. If you were adding numbers from 1 to any number, you will, for example, 1 plus 2 is 3, 1 plus 2 plus 3 is 6. You know, suppose you continue doing that, you know, let's say you want to add up to 100. Of course, if you have some time and paper and pencil, you can do it. I mean, you know how it can be done, okay? But if you don't have time, you just think about it and say, yeah, it can be done, but I don't have time to do it right now. So then what I wanted to know is how I could find a simple way that, you know, to do that. And so that took me into sitting down and trying to find a formula, a mathematical formula, which in many ways is transformation. You transform that tedious problem into a form that's also geometry. That's the gift of the ancestors. You transform into a space where it is easy to do, okay? And so after struggling with it for a couple of days, I came up with a formula, which was if the number that you stop in was n, you know, as an arbitrary number, then the sum, adding the number from 0 or 1 to that number n, will be equal to n over 2 multiplied by n plus 1. Okay? And I did that, and then I plugged in n over 2 multiplied by n plus 1. So, of course, if you add 1 plus 2, you get 3. So 1 plus 2 means that you're stopping at 2. So 2 over 2 is 1. 2 plus 1 is 3. So 3 times 1 is 3. That's the answer right there. And you can plug in any number, even a million, okay, which certainly even a computer will take some little time to do that. But there is one that could take the computer an impossible time to do. Okay? But this formula can do it. Because all you need is, you find a number where you start. Suppose it's 10 to the power a million. Okay? 10 to the power a million. That's going to take a computer a lot of time to do that. But all you need is you have your 10 to the power a million, you divide it by 2, add 1 to it, and and then maybe I don't yet. Okay, the formula that I'm talking about is okay. Thank you. What I'm talking about is the sum. If you're adding 1 plus 2 plus 3 plus to n, okay, say that is equal to, okay, S of n. S of n is equal to n over 2 n plus 1. This is what I found in the high school. And like I said, if, let's say n was equal to 10 to the power a million, okay, to 10 to the power 6. You try giving that to the computer, though. I mean, let the computer add that kind of number. That's going to be horrible. But technically, you will have that as S 10 to the power 6 is equal to, you just substitute it here, 10 to the power 10 to the power 6 over 2 into 10 to the power 10 to the power 6 plus 1. That's an answer. The computer will have a difficult time trying to do that. It will be crunching. You may run out of energy before it gets to do that. So that is the power of transformation. Okay? There is a transformation. You transform this difficult problem into a space where it's very neat and simple. And that's the basis of the unified field theory. It turned out that this formula that I did in high school was the same formula when I took it to my teacher. I guess he was a Frenchman. He looked at it and he basically, he gasped, and I think he almost had a heart attack when he saw that. He was the math teacher. And he said to me, "Do you know what you just did?" And I said, "No, I don't know. I thought I just found the formula." And he said, "Does the name Gauss mean anything to you?" This is Gauss. "Does the name Gauss mean anything to you?" I said, "No, I have no idea who he is." But he says Gauss is considered, along with Newton, okay, and Euler. Of course, he was a European, or he's a European. These are the greatest mathematicians of all time: Gauss, Newton, Euler. And this guy came to fame by finding this formula. This was his thing his claim to fame, as they say. So how did you do it? He says to me. I said, I just sat down and I looked at that and I put that end down. I tried to do some little serious thing, and that's what came up. So from then, of course, I would earn a nickname of Mr. Calculus. That was my nickname in high school. By the time, of course, I got to 10th grade, I became a teacher of calculus. Okay? So you would have thought that I was going to be teaching, 9th grade is where people start calculus, teach 9th grade. But I wasn't teaching 9th grade. I was not teaching 10th grade. I was teaching 12th grade. And actually it was what they call popular demand by the people in the 12th grade who were my seniors. And the boarding school that I went to, being a senior was a very significant thing. I had to wash their clothes, at least up until that point. I do the laundry for them. I mean, because they were 2 years ahead of me. In fact, even 11th graders, that's the tradition in the high school. So, but when it came to being a teacher, they had no problem, say, yeah, let that young man come and teach us calculus. So they would take me there, and but I was rather small, so there was a little chair that I had to stand on to give my lessons. But it was fun, they had fun just as I had fun. So, but this name stood with me throughout. As a matter of fact, there are some of my classmates that still address me with that name. One wrote me a letter a couple of years ago, and I still remember that after 30-something years. So the kinds of circumstances that surround the search, but part and parcel of this kind of development in terms of mathematics is the philosophy from the elders, the African philosophy, which was luckily quite alive and well in the environment that I grew up. Okay, you were taught your history. You were taught who you were. You were taught about the war you lost 500 years ago. Okay, and how you became a POW, a set of POW, in 3 categories. One that were left on the continent, one that were dumped in the Atlantic Ocean, and one that came to the New World and other places. And so in other words, you were geometrically and spiritually in a plane where you had information. You were quite and then the other thing they would have us do is to trace our ancestry. Okay, back as far as you can. Okay, I can easily trace mine to 1100, and by projection back to the pyramid years, Egypt. Okay, and so every young person, to show that you grew up well, that you are a true black person, you're an African, and that knows him or herself, you have to embark on doing stuff like that. So you're not just black and proud, per se. You're black and proud because the glory of the Almighty God that blessed you with so much. Okay, so much food, so much knowledge, so much mathematics, so much civilization, in the cradle of civilization, so much history, so much love for humanity and all that. So you got to go through this. And what that does is really keep you continuously in a state of positive experience. And that, nourishes your development. It energizes you in terms of your growth academically, spiritual, and so on. So all that added to the search for the unified field theory. So with things like this, I would move on to the university, and one of the pieces that was done in the undergraduate was a study of the rocket. I did in a book called, it's a published book, okay, the gas turbine testing, okay, by myself. I basically studied the principles of rocketry and how math plays a role in that, okay? And I remember a professor by the name of Professor Peter Wojcik, okay? A very brilliant Polish professor described this piece as a masterpiece. Those were his word. That was his word in describing the gas turbine testing. So again, there was an application of mathematics, the philosophy, the African philosophy, and you know, and the appreciation of what the giver of knowledge, who is the Almighty God, has done. So then we moved on from there. At this point, of course, one of the things that I was quite interested in doing was making sure that the gifts that seem to be apparent in my system with mathematics was not just trivialized by people who look at mathematics as some form of abstract thing, you know, that has no use except for some trivial self-gratifying kind of feeling, you know, that you're supposed to get from abstract mathematics, okay? So, for example, getting that formula, to me, had a lot of practical implications. It isn't just some abstract thing. It has, like I showed, the comparison between that formula and the computer. There is certainly an advantage. So then, I wanted to make sure that people did not misunderstand my role as a person that studies mathematics. I hated being written off as some, you know, somebody abstract that has no impact on the humanity or practical situations. So I made sure that whenever I develop the mathematics, I would look for an application. This was the first practical part, you know, in terms of, you know, the university years, okay? Because what happened was, that, I probably need to cover it. What happened was that the math helped me see rocketry, because this basic book here deals with rocketry, gave me an insight into rocket science. And to, again, get back to my base as an African in terms of where such an idea could have come from. Later on, I would come across the name of Andrew J. Beard, an African born in this country who had no formal education, invented a rotary engine, okay? Rotary engine, which is basically the principle of the rocket. And the interesting part about Brother Beard was the fact that they said that he didn't have any formal education. So then you ask yourself, how does a person walk off the street or walk off his mother's womb and create a revolution of this type? Of course, he is an African. That was a good beginning. Then come to find out, there is a toy, in other words, trying to explain this revolution, there is a toy called Chico, which is an advanced toy for an African child. Okay? And Chico is something of this okay, something like that. And it's got another component like that. Okay. This is cylindrical, and this is also a little cylindrical, and it's got a piston type thing here. And what happens is you can insert a bullet-like thing over here at the, it's hollow. It's like a bamboo or something like that. They build it from. So you have this piston here, and the handle, and there's some brush at the end of the piston. Okay, so you could move it in and move it out. The brush serves as a valve. There's a valve there that when you're going in, there is a compression of air if you allow air in to begin with. And then when you come out, of course, it expands and so on. So this is a toy that an African child uses. And what happens is, with this bullet in there, you can compress enough air in here to project, and send this out as a projectile, okay, or like a bullet, okay? So I looked at that, and I said, my goodness, then probably it's a relationship with that, the cheekbone, and the rotary engine, that occurring in Africa, and this man being an African. If he didn't have a formal education, the only education he had was what his father and great-grandfather taught him, which is the African education. And so there was a theory that says that is linked to cheekbone. So again, rotary engine connecting with gas turbine, and then with cheekbone. Of course, for most people who understands the good part of the other history of the African, in terms of the pyramids and so on and so forth, that is not far-fetched. That's a neat kind of thing. So this was the kind of thing that one picks up as you move on in the search for unified field theory. Every time you get something of this kind, there is a reinforcement in your efforts in terms of your determination to get the job done. So we moved on from there. By the end of this project, after having demonstrated, especially with this guy here, fine professor, Professor Wojcik, calling this work a masterpiece, that was well appreciated, and then energized me further. So then got into a field called, a field of transformation called affine transformations. While actually in high school, what I would do is, in terms of my search for the unified field theory, first I wanted to understand the relativity theory. And I remember every time I would go to the library, I would go to that section, of physics and mathematics where, there would be books on physics and relativity. And each time I would pick that up, the other kids would laugh at me. Even other grown-ups would laugh at me and say, "Gee, what a crazy guy, look at the kind of crummy book he's looking at." And Michelson and Morley experiment in terms of ether and all that, I will read that over and over. And the Lorentz geometry, quite vivid. I remember the books, Dover type books, that were, and I would read that over and I would, and I'd say, gee, wouldn't it be nice if one can go beyond where they are? I'll read and just get information and move on. So eventually, the field of transformation called the affine transformation. I began to get into that. Of course, that's the same transformation that Lorentz used in explaining the special relativity. That developed, and in the process, of course, I met with a professor, in my graduate years. Actually, yeah, my graduate years. I met with a professor, a very renowned professor, called Eugene Brunel, E.J. Brunel. Eugene Brunel got all kinds of awards in MIT, became one of the youngest professors to ever be appointed at Princeton University. In fact, one of his students became the chairman of Grumman Aerospace. Renzo Caporelli was his PhD student at Princeton University. So I met him, and he was quite advanced in affine transformation studies, had developed some really neat stuff. And so I began to work with him, along with some very notable other mathematicians like George Handelman, Bob Lowe, and Henry Nagamatsu. These are some of the finest scientists and mathematicians that I was blessed to work with. So in the process, wrote some, PhD thesis that did a lot of analysis of affine transformations, from geometric, spiritual, aeronautical, and all kinds of dimensions. And that work received a lot of, how can I say it, praise from the mathematics and engineering communities, because it has application to aeronautics. So that, again, energized me quite a bit. And so the fact that it had been used in relativity was always there behind, in my mind. Something that was used in relativity that is quite abstract could indeed have applications in aeronautics, designing airplanes to be safe. So I said, gee, there must be more to affine transformations, because what affine transformation did in relativity was to really explain the concept of special relativity, which in a specific form, which is the wave equation is a well-known equation in mathematics. But in terms of explaining physics, The special relativity calls for a transformation of that wave equation into a certain mathematical space. And this affine set of transformation that the special one that Lorentz chose could transform that equation in such a neat way that the character, the properties of the waves were preserved. Okay, there was no changes at all, and that was also one very significant. In the process, of course, he explained what special relativity was talking about, to the joy of Albert Einstein. And of course, that energized Professor Einstein to go further, into this general relativity, and beyond. And so I took note of that, but my first application, of course, was the aeronautical application in aeronautics, where obviously there are some significant problems. Most people may not realize the connection, tight one, for that matter, that exists between what you call physics and aeronautics. Aeronautics is the physics of gases and bodies that fly, through air, and so on. And so it's very much like studying physics. For one thing, air is basically composed of particles, molecules of nitrogen, oxygen mixture. And so, when you're looking at a flow, it's like looking at particle physics. And especially when it gets into the rarefied mode, then of course you're really looking at the particle. So the equations, the same equations, are used to describe those kind of aeronautical systems. So it was not totally unconnected what was happening there. It was studying physics. So, so that development received a lot of attention. In fact, in terms of research citation, the last time I count, we had, I noticed that I had over 100 citations, in terms of other researchers using, works like those affine transformation works and the current work and so on and so forth. And 100 citations is it's not a bad number at all. So then